Okay, now let's talk about the flip fluid's viscosity to create the viscous fluids. So let's create a geometry node and dive inside, and in here let's add a sphere. Okay, so this is the sphere that we are going to use for the emission. So let's move the sphere up, let's change the center. Okay, and in here let's add a trace geometry shader ball. Okay, so let's use this geometry as a collider. So here onto the uniform scale, let's set the scaling of the shader ball to 3, and let's set the display flag to the sphere node, and let's template the shader ball. Okay, and we need to change the center of our emitter, and let's move the sphere up. Okay, and after that, here onto the sphere, let's add a flip dop source node, and let's connect this. And here onto the flip dop source, we have the particle separation, so we will link this with the flip object particle separation. Okay, so in here let's add a dop network. Let's connect the dop network, and let's connect this one to the first input, collider to the second input, and let's dive inside, and in here let's add a flip object and a flip solver, and let's connect the flip object to the flip solver, and let's add a gravity force in here, and let's connect this, and let's import our shader ball sphere for static object. So let's create a static object in here, and onto the static object let's select the saw path. So from here select the shader ball. Okay, and now let's add a merge node, and let's connect this and the static object, and into let's organize the static object. Okay, and here we have the effector relationship, left affect the rights. Okay, so here onto the flip object, let's remove this initial default fluid. So let's remove this saw path, and let's import our source with the volume source node. So let's add a volume source node, and let's connect this into the sourcing, and onto the volume source let's choose the input to the first context geometry, and onto the initialization let's initialize this to source flip. Okay, so now it will import the particles as well as the surface field, okay, from the SOP level. So let's go into the flip object, and onto the guides let's go into the particles guide and change the visualization to particles. Okay, and now let's link this particle separation. So let's copy this parameter, and onto the flip source node let's paste this into the particle separation. So paste relative reference. Okay, and now let's dive inside and hit play. Okay, so we have a very big domain. So let's go into the flip solver and onto the volume motion. So here we have the flip domain. So first let's change the color of the guide, and let's change the box size. Let's change the size to 10 by 10 by 10. Okay, and let's see, and let's move the box center up. Okay, so maybe let's change this to 6, and let's add this 3. Okay, so now it is perfectly sitting onto the floor, and now let's hit play and see the result. Okay, so the fluid is cutting off. So let's go into the flip object, and let's enable the close boundaries. Okay, so now our fluid is colliding. So to add the viscosity to these particles, let's go into the physical tab, and here we have the viscosity. So let's increase the viscosity. Let's change this to 100 and let's check. And here, as you can see, we have no effect. So let's go into the flip solver and let's go into the viscosity. So here onto the volume motion and into the viscosity, let's enable the viscosity. Okay, and now let's see the result. Okay, so here, as you can see, the viscosity is working. So let's increase the particles count. So let's go into the flip object and let's lower the particle separation down to 0.05 maybe, and let's check. Okay, so here we have the viscous fluid. So maybe let's increase the viscosity. Let's change this to 1000 and let's see the result. Okay, so now we have a very viscous fluid. Let's keep increasing the viscosity and let's hit play. Okay, so now we have a very stiff fluid. Okay, so let's lower down the viscosity value and let's check again. Okay, and now let's animate our source. So let's go into the geometry level, and after the flip source, let's add a transform in here. Let's connect that, and here onto the transform, let's animate the translation Z. So to animate, let's use the sine function. So in here, let's type the sine, and here onto the sine, let's use the $sign F for the current frame number. Okay, and now let's see the result. Okay, so now we have a very low frequency sine wave. So let's multiply by this by 3 to increase the frequency of the sine wave, and let's check. Okay, and let's also enable the real-time playback and let's see the result. So maybe let's increase this to 4. Let's add a 4 in the multiplier and let's check. Okay, so the value of 4 is looking good. So now let's go into the .NET and let's see the result with the animation. Okay, so here we are adding the viscous fluid. So you can use the viscosity to create the honey or chocolate simulation. Okay, so now let's add a noise into the velocity. Okay, to break up the fluid. So let's go back, and after the flip source, let's add a point velocity node. Let's use the point velocity and let's connect that. And onto the initialization, let's change this to value and let's give him a -1 value in the y-axis, and let's also add the curl noise, and let's also increase the scale. Maybe let's increase the scale to 3, and let's dive inside and let's see the result. Okay, so now we have some breakups due to the velocities of these particles. Okay, and so let's increase the particle separation to create a more higher sim. So let's increase the particle separation to 0.01 and let's check. Okay, so when we change this to 0.01, we have a lot more particles and simulation is too slow. So maybe let's change the particle separation. Let's change this to 0.02 and check. So let's change this to 0.02. and now let's see the result. Okay, so value of 0.02 is working good, so we have a nice speed. Okay, and we have enough detail. So if you want to add more noise detail, you can always use these particles velocities, particles forces. Okay, so in here let's go into the point velocity. Maybe let's lower down the scale and let's check. Okay, so now the scale is looking good. So after that, in here let's add a pop force node. Let's add the pop force and connect this into the particle velocity, and in here let's increase the amplitude. Let's change this to 3 and let's view the results. Okay, so now we definitely have some noise. So here we have the very viscous fluid. Let's simulate this fluid for a couple of frames. Okay, and okay, so the 62 frames has been simulated. So let's see the result. So let's hit play. Okay, so here we have the viscous fluid. So that's how you can use the viscosity inside of flip fluids. Okay.